So in this video we look a little more closely at the absolute value of a number, and we look at it from the point of view of functions. So f of x here is absolute value of x. And one good way of looking at the absolute value of a number is that the absolute value is the distance from a number to the origin. The origin, the number 0. Okay, so if you've got a real line and you've got a number here, the absolute value is how far 3 is from 0. It's 3 apart, right? They're 3 apart. But if you've got minus 4, it's the absolute value is 4 because it's at a distance of 4 from the origin. So we can actually tell that there's a formula here for f, but there are two rules. Either it's x if x is positive. For example, if it's 3, it's 3. But if x is a negative number, it's the opposite of that number. So for example, if it's minus 4, it's the opposite of minus 4. In other words, it's 4. Okay, so this tells us that the absolute value function is in some way a piecewise function comprised of two lines. Okay, we can actually sketch it. Okay, if we want to sketch the graph, okay, we can just use our knowledge of piecewise functions. So it's x if x is greater or equal to 0. Okay, and it's minus x if x is less than 0. Notice I put an empty dot there because at 0 that's not the rule that applies. But if I add the two here, I'm going to get the graph of the absolute value function, which is a piecewise function. But if I glue the two, actually maybe I should have drawn the other part in blue as well. If I glue the two together, I get this V shape. Okay, and essentially the first line was a line with a slope of 1, right? Because it's 1x. Here it's minus 1x. So here the slope is minus 1. So it's the same thing here. Here you've got a slope of 1 and a slope of minus 1. And that means that this goes through 1, 1, 3, 3, and so on. And here it's minus 3, 3. And so on. So actually you can see it's an even function. So this is also true. So f is even since f of x is the same as f of minus x. And that's true because if you've got absolute value of kx, that's the same thing as absolute value of x, absolute value of k, absolute value of x. So here, if k is minus 1, you're going to get absolute value of minus 1 times absolute value of x, and that's basically 1 times absolute value of x, which is absolute value of x. So it's an even function, so that's why it's symmetrical with respect to the y-axis. Okay, so we can add this to our toolkit functions. Okay. And now we're gonna sketch the graph of we're gonna find a formula given a graph of an absolute value function. So this is actually figure 4 in your book for section. So this is section 3.6, and it shows you a V shape that has a vertex as 3 minus 2. It crosses the x-axis. What did I do here? Crosses the x-axis at 4, 0, and the y-axis. So the y-intercept is 0, 4. So it looks like that. Okay. Okay. Now it's going to be the graph, or it's going to be related to the graph of an absolute value function if the slopes are identical on both sides. So if you have different slopes, it's just a piecewise linear function, but it's not related to an absolute value function. So maybe one thing to check, and they don't do this in the book, but we're going to check that it's actually the two slopes are opposite one another. So here the slope of this part of the line, well, it's going to be, I take the 2 points, right, this one, and I subtract their y coordinates. So I get what, 0 minus 2 over 4 minus 3. So that gives me 2, doesn't it? Yes. And on the other side, if I get a slope of minus 2, then I know that I can relate this to the graph of an absolute value function. So same thing here, delta y over delta x. So that's 4 minus 2 over 0 minus 3. So that gives us 6 over minus 3, which is minus 2. Perfect. So they're equal in magnitude, but opposite to one another. So this is definitely a transform absolute value function. Okay. Now I can see the vertex ends up at 3 minus 2. So already I know there's going to be, just from this, I know there's going to be a shift 2 down, 3 to the right. Okay. Now the slope has changed. Okay. So it's actually steeper. So before we had a slope of 1, now it's a bit steeper. It's a slope of 2 and minus 2. So what happened there is some sort of it's a horizontal compression. Okay. Okay, so there's some sort of horizontal compression. Okay, so maybe what we can do is try to generate that graph starting from the absolute value function. Maybe that's a good place to start. Okay. So now I'm gonna perform a transformation that changes the slopes. Okay. So here slope is 1, slope is -1. So remember that in the way the absolute function is defined, right? The slopes, they sort of appear here, right? So if I replace, say, x by, let's say, 3x, okay? Here it's going to be 3x if x is greater or equal to 0, minus 3x if x is less than 0. So by putting a 3 or a 2 or any number, that's going to change the slope of my piecewise function, right? Because 3x is aligned with a slope of 3, minus 3x is aligned with a slope of minus 3. So by changing the number inside of the absolute value, now currently it's 1, but if I change this to, let's say, I want my slopes to be 2, so I'm going to put 2x here. So by doing that, okay, now you see this is going to be 2x if x is greater or equal to 0, and minus 2x if x is less or equal to 0. It really changes the slopes. So it's compressing. So I'll tell you what, it's a horizontal compression, but you can also see it as a vertical stretch. Okay. So either it's a compression of a half horizontally or a stretch of 2 vertically, because you can pull out the 2 outside of the absolute value, because absolute value of 2x is absolute value of 2 absolute value of x, so that's 2 absolute value of x. So you can either see it as a vertical stretch or a horizontal compression. Okay, so here vertical stretch. So right now I actually did a compression, so maybe I'll start with that. Horizontal compression of 1/2. It's compression because it's narrower now, or it's a vertical stretch of 2. So you can see it either way. It's a vertical stretch now because it's higher. Okay, and now all I want to do is shift. So the slopes now are 2 and minus 2. And now we just need to shift the vertex. So how do we shift? Okay, so currently what we did, right? You had f of x, now we have f of 2x like this. Now to shift it, I need to do f of 2x minus h plus k. Okay, but f is the absolute value function. It's going to be absolute value 2x minus h plus k. So this is what my f of x is going to look like. So I need to know what h and k are, but I know, right? It's a shift 2 units down. So 2 units down, it's actually the k, so 2 units down here, so minus 2, and 3 to the right, which means it's x minus 3 here. So I shouldn't write f of x, this is y here. Okay, f of x is my original function, absolute value of x. So we've got our equation here. So if we do that shift, we're going to get the graph above, like that. So our origin, which was the vertex of our parabola, now becomes 3 minus 2. And the slope here is 2, and those slopes are unchanging if I shift, minus 2. So I'm really getting the original graph. I can just double check. If I replace x by 0, I should be getting this point, right? I should be getting 0, 4. If I replace x by 4, I should be getting 0. I could verify. So let's check. Okay, if x is, what did I say? X is 0, what do we get? Y is 2 times minus 3 minus 2, so this is absolute value of minus 6 minus 2, so this is 6 minus 2, 4. So that's correct, it's 0, 4 that I was expecting. Okay, if x is 4, I should be getting a y value of 0. So 2 times 4 minus 3 minus 2, so that's absolute value of 2 times 1 minus 2. It's absolute value of 2 minus 2, which is 2 minus 2, which is, bingo, 0. See, that works. Now maybe one last question. What if for my graph I want to have the x-intercepts? Okay. So what are the x-intercepts here? What do I need to solve to find my x-intercept? Well, I need to solve f of x equal to 0. I need to find where the y coordinates are equal to 0. So here, my function I set it to 0 and I try to solve for that. So 2x minus 3 absolute value. It's a bit sloppy here. Okay, like that is equal to 2. And then I get either 2 times x minus 3 is equal to 2, or its opposite is equal to not its opposite, or the exact same expression is minus 2. Those are the two possible cases, right? Either inside the absolute value it's 2, or it's minus 2 to get an absolute value of 2. So then I just solve for x. So divide by 2 on both sides, add 3, or in here divide by 2 on both sides, add 3. So I get x is 4 or x is 2. So the x-intercepts are going to be 4, 0 and 2, 0. So I can add that to my graph. This is 4, 0. Actually, I knew that, right? It was given to me over here. And 2, 0. 2, 0 is the other one. Which makes sense, by the way, because it should be symmetrical with respect to the vertex. So the 4, 0 is 1 unit to the right of the vertex, so the other would be 1 unit to the left. And that's it.